Okay, we've got one more type of sequence and series we're going to talk about, and those are geometric sequences and series. So the definition says, suppose that we've got a sequence. If there's a number r so that the next term is r times the term before that, then it's a geometric sequence, and we call r the common ratio. So here, instead of adding, you're multiplying each time. So this says, find the common ratio of these geometric sequences. So we're going to kind of plug some values in to figure it out. So first we're going to plug in 1. So we'd have 6 to the 1 minus 1 over 7 to the 1. So this would be 6 to the 0 over 7. The next term we'd be plugging in 2. So we'd have 6 to the first over 7 squared. Then we'd have 6 squared over 7 cubed. And I hope you see what's happening. Each time we're multiplying the top by 6, we're multiplying the bottom by 7. So our common ratio would be 6/7. Okay, here, first we would plug in 0. So we'd have -1 to the 0 over 2. So this would be 1/2. A2 would be 1 over 6 plus 2 would be 8. A3 would be -1 over 11. Now, notice here that these values, you can't divide them and get the same thing. You can't multiply by a number and get this. So this is actually not a geometric sequence. So there's no r. Now, just like we had for the arithmetic sequences, we have some formulas. So the sum of the first n terms of a geometric series, where r is your common difference. Okay, if your r is not equal to 1, we have this formula. And if your r is equal to 1, it's a little bit simpler. So we're going to find a sum here. So we're going from 1 to 14, so our n is 14. This should be A1, your first term. So our A is 3. Or sorry, 3 times 1/5, so 3/5. And our r here is 1/5. So we're going to plug this in. We'd have our sum would be 3/5, 1 plus 1/5. We're going up to 14 to the 14th, all over 1 minus 1/5. Now if you put this in your calculator, you get 0.75 and then a bunch of zeros. So this is approximately 0.75. Now, if your r value is less than 1, if the absolute value of it is less than 1, we can actually find the sum of an infinite series, so if you're adding forever. And the sum of an infinite series, you take your first term over 1 minus r. So here, for this one, 1/2 plus 1/4 plus 1/8, we're multiplying that by 1/2 each time. So we'd have 1/2 over 1 minus 1/2, which would be 1/2 over 1/2. So our sum would actually be 1.